Girls, and today we are going to be talking about vertical motion word problems. And these word problems deal with the quadratic equation and understanding word problems that deal with parabolas. Before we start, I'd like to talk about a formula that you do already understand, the distance models. And the distant model means that distance traveled is equal to rate times time. So we have three variables. D is the distance, R is the rate, T is the time. And for the distance model, the rate is constant and the relationship is linear. So let's go through this motion problem, which is linear motion, with this simple example. A car travels at 50 miles per hour. How far will the car travel in 0, 1, 2, 3 hours? Complete the table and graph. So we're going to go back to talking about key information. So here we want to find out a car travels, how far does the car travel? So that's what we're looking for. We're looking for the distance. So the distance we don't know. And the rate the car travels is 50 miles per hour. So the rate is 50 miles per hour, so we can fill in the rate of 50. And the time, to make this an equation, we're going to use time, but we're given several times. So we're going to use this equation, and if the car is traveling 50 miles per hour, how far has it gone after 0, and time is measured in hours, in 0 hours? Well, it would be 0. It starts at 0. If the car has been traveling for 1 hour, then it's going to go 50 miles. 2 hours, it's going to go 100 miles. 3 hours, it's going to go 3 times 50, 150. So we're going through this motion problem, and the rate is a constant rate. So if we then take this, time is in hours, distance is in miles. So we plot our points, 0, 0, 1, 50, 2, 100, 3, 150. Right? So that car is going to keep traveling, and after 4 hours it's going to go 200 miles. So this is a linear relationship. So now we're going to go to vertical motion problems. And before we get into the definitions, the graph of a vertical motion problem is a parabola. And so some examples would be if we have a missile here and we shoot it in the air, okay, and we have a plane coming through, we could possibly hit the plane. Okay, so the plane is coming across and we shoot the missile. The highest point that the plane could be flying for us to hit the plane with this missile would be at the peak. And the peak, remember, for a parabola is going to be the vertex. Now, if the plane is flying lower than the vertex, okay, then that missile could possibly hit the plane on the way up, or if the plane was going slowly, on the way down. Right? So this is a parabola. Okay, another example would be if you kick a soccer ball in the air, you're going to kick it, it's going to go up and then in the air, and then it's going to come down to the ground. So let's discuss vertical motion models and the definitions for it. Okay, so vertical motion models describe the height of an object, how high the object is, that is propelled into the air, but has no power to keep itself in the air. Okay, so what goes up must come down. The equation for vertical motion is h equals negative 16t squared plus vt plus s. And the vertical motion problem that we're going to be doing is going to be based on using feet and seconds. Okay, so let's talk about what the h is. Okay. So the h is the height of the object in feet. So if I have my missile, okay, here is the height of our plane when our missile is going to be shot, or how high the soccer ball is when you kick it at a certain height. Okay, so that's the height of the object that you're trying to measure. T is the time the object has been in the air. So here the missile could be here, or the missile could be coming down here. So we have two possible times. This is time on the way up. Okay, so if we have our missile being shot in the air, it goes on this parabola. Okay, so the time on the way up of that missile is here, and then the missile is going to go up to its peak, which is the vertex. It's going to come down. So this is going to be the time on the way down. Okay. And this is going to make a lot more sense when we start doing the word problems. Okay. Okay. V is the initial vertical velocity. Okay. And that V is how hard you hit the impact of that missile going up into the air. So that's the initial vertical velocity. Okay. The S is the initial height in feet. So for this example, this is ground level. All right. So ground level. So in this case, S is equal to 0 feet. Okay. This is at ground level. Okay. So we have the height here. right, of our object, the missile, right? And then we have two possible heights. We have two possible times. Here is the velocity for the initial velocity. And then we have to have a factor that takes into account gravity. So we're going to be using gravity used for feet per second. So this factor is -16. Takes into account the effect of gravity, but ignores other less significant factors such as air resistance. And in your science classes, you're probably going to learn a lot more about this. But we're going to learn about the mathematical part. So the formula is the height is equal to -16 t squared plus vt plus s. So now we are going to do some sample problems. Now you'll notice that these notes are coming from chapter 9. Okay. If we have a quadratic equation, okay, we can solve it several ways. We could solve it by graphing. We could solve by factoring. If it's a really easy problem to factor, then solve it by factoring. Or we can solve it with the quadratic formula. Okay. So let's go through and do this problem. And your key information every time is going to be a picture. So we have a fountain. A fountain sprays water into the air with an initial vertical velocity of 20 feet per second. After how many seconds does it land on the ground? All right, so we have the fountain. All right. A fountain sprays water into the air. So we have our fountain, and the water goes up into the air, and then it comes down. Okay, and this is where it lands. Right? So the initial vertical velocity, so the velocity is 20 feet per second. After how many seconds does it land on the ground? Okay, so we are looking for time. And now remember the formula. Here's the formula that you need to memorize. Okay. So we're looking for time. We know what V is. We need to find S. So S is where the fountain is, and the fountain is at 0 feet because the fountain is on the ground. And the water sprays out of the fountain, it lands, and we want to know, okay, when it hits the ground. So the water sprays, so we want to know when H, the height of the water, is when it hits the ground, and that's going to be at 0 feet. So we know that V is equal to 20. We know that S is 0. So we can plug this into our equation. The height is equal to negative 16t squared plus V, 20t, plus S, which is 0. So we can simplify it. This is 0. So we have h is equal to negative 16t squared plus 20t. Okay. So we have this equation, and now step 2 is that the height, we're looking for the height when it hits the ground. So the height is going to be 0. When the water lands, its height above the ground is 0 feet. So now we're going to replace the height, which is 0, minus 16t plus our 20t. All right. So this is an easy problem to factor. Right? For these problems, you can solve them by factoring, or you can solve them with the quadratic formula. So we're going to solve this. And we take out our common factor. Now we have a leading coefficient which is negative, so we want to take out negative 4. And we have t, which is common to both. And we're left with 4t minus 5. And we can mentally multiply that. That gives us our negative 16t squared plus 20t. And remember, to solve, we set each factor, negative 4t equals 0. Okay. Remember, this must be 0 in order to solve it by factoring. And we have 4t minus 5 equals 0. So here, okay, negative 4 times 0, so I get 0t equals 0 feet. That's one solution. And here t equals, mentally add 5 to both sides, divide by 4, 5 over 4. Oh, it's not feet. Sorry about that. We won't deal with that. These are both in time is seconds. So what does this 0 mean? The solution t equals 0 means that before the water is sprayed, its height above the ground is 0 feet. So this is at 0 seconds. And then it goes up in the air and it lands down here at 1.25 seconds. So the water lands on the ground, okay, at 1.25 seconds after it is sprayed. So let's just go through and review the quadratic formula. So we have our quadratic equation, and remember the standard form is 0 equals ax squared plus bx plus c. Okay. And so our equation is 0 equals negative 16 t squared plus 20t. So A is equal to negative 16. Okay. B is equal to 20. And C is equal to 0. So we're not finding X. Okay. We want to find T. So we're replacing the X with T. So T is equal to the opposite of B, negative 20, plus or minus the square root. Okay, 20 squared is 400 minus 4 times A times C, all divided by 2 times A. So T is equal to negative 20 plus or minus, okay, this is going to be 0. So it's the square root of 400. And don't forget, divided by negative 32. So we're going to get T equals negative 20. The square root of 400 is 20, divided by negative 32. And we're going to get T is equal to negative 20 minus 20 divided by negative 32. So this is going to give us negative 20 and 20 is 0. So this gives us our T equals 0. Okay. Put into your handy dandy calculator negative 40 divided by negative 32. And you're going to get T is equal to 1.25. So you can see in this example, which way would you want to solve this? Would you want to solve this by factoring? Or would you want to solve it by the quadratic formula? And in all these problems, you have that choice. So there's a problem. Let's do another example. Let's see. All right, so we're going to have our key information over here. An athlete hits a tennis ball at an initial height of 8 feet with an initial vertical velocity of 62 feet per second. All right, so we have our tennis player. Okay, and he's got the tennis racket. Okay, and these do not have to be fancy. The ground is here. He hits the ball. Okay, and it's going to land on the ground. So we are also told the vertical velocity. So we're told that V is equal to 62. Okay. Okay. So do we have we put all the information here? An athlete hits a tennis ball at an initial height. Okay, so the initial height, is the starting height. So the initial height is going to be 8 feet. So the ball, okay, is going to be 8 feet. Well, actually, it would be to the tennis racket, but I think so the initial height actually is like this. Okay, because this is where the ball is. You've got the tennis racket extended, okay, and you've got the person, and he hits the ball with the tennis racket at 8 feet in the air. So A, write an equation that gives the height in feet of the ball as a function of time since it left the racket. So we're going to do A first. So we're going to use, to write this function, we're going to use the vertical motion model. Okay, and that is simply this equation here. And you need to memorize that. So it asks us to write the height in feet of the ball as a function of time. Okay, so we have the height, the velocity is 62, and the starting height is 8. Okay, so this is the equation that you would use to find any height. So now, to find the number of seconds that pass before the ball lands, find the value of t for which the height of the ball is. Okay, so it asks for when the ball lands. So that means that the height is equal to 0 feet. When does it land on the ground? So we're going to substitute h with 0. Okay. For which the height of the ball is 0. And we substitute 0 for h. And we bring down the rest of this formula. So 0 equals negative 16t squared plus 62t plus 8. All right. And I'm going to solve this by factoring. You could solve it with the quadratic formula, okay, but I think that this is going to be easier to factor. So I'm going to solve it by factoring in this example. Okay. And so we have 0. We're going to factor out, well, we don't like that negative number, so we're going to factor out a negative 2. And then we're left with 8t squared minus 31t minus 4. All right. Now, I take that back. This is a difficult problem to solve by factoring. So, in this case, you might want to solve it with the quadratic formula. But to go through the mechanics of doing these problems, I'm just going to show you how you would factor this. But if you saw something like this, I'd say, nah, I'm going to use the quadratic formula. So if I were to factor this, it would be 8t plus 1 and t minus 4. And you can check that. 8t squared negative 32t plus t is negative 31t. 1 times negative 4 is negative 4. But if you get a problem like this, try to solve it by factoring, but solve with the quadratic formula for this problem in the future. So now we have to take and we set each of these equal to 0. Now, there's no variable here, so we can ignore that. So we're going to get 8t plus 1 equals 0. And we're going to get t minus 4 equals 0. And we're going to subtract 1, divide by 8. So here we're going to get t is equal to negative 1/8. Or add 4, t is equal to 4. Okay. Now, the question is, when does the ball hit the ground? Well, the tennis ball is going to hit the ground at 4 seconds. But what's this thing here? We have negative 1/8. All right? A negative solution doesn't make sense. So we are going to, this is impossible. Okay? And so we're going to discard this solution. Okay? So the time that it hits the ground, the ball hits the ground, is at 4 seconds. Now the reason that we get a negative number is that if we were to complete this parabola, it would be back here. Well, we can't have negative time, right? So this does not make sense. Okay, so there we go. That's the next problem. And then the last problem that I'm going to do on this video is the next one. And then for homework, you are going to finish this packet. So let me see if I can locate So here's a different type of a problem. We've got a falling object. And so we've got our key information. A brick falls off a building from a height of 144 feet. How many seconds does the brick land? After how many seconds does the brick land on the ground? So I want you, for all of these problems, you've got your building, and it's got its door, and it's a brick building. So we have a brick here. Okay, a brick falls off the building from a height. So this is the initial height, and the initial height, remember, is S equals 144 feet. And the brick just falls off. Okay? and it lands on the ground. Okay. And when it hits the ground, the height of the brick is 0 feet. Okay. So we understand that here is the brick. Our starting height is 144 feet. It falls off. The height is 0. It just fell off. All right? There was nothing that propelled it. It wasn't like a soccer ball that gets kicked or anything like that. So our initial velocity is going to be 0 feet per second. So I want you, for every vertical motion problem, I want you to do the key information with a picture. I want you to identify the velocity, the starting height, and the height of the object that we're looking for. So let's go through this problem. Solving by factoring. Use the vertical motion model. The brick fell, so its initial vertical velocity is 0. Find the value of time for which the height in feet is 0, because it's when it hits the ground. Okay. So the vertical motion model is a function that has h. The height is equal to negative 16 t squared plus, okay, vt plus s. That's the vertical motion model that you have to memorize. And we're going to substitute the values. The height, when it hits the ground, is 0. Negative 16 t squared. Okay, because remember, that's gravity. That's just a factor for gravity. Plus v. Okay, so that is 0 t plus the starting height of 144. Okay. Now, we know that this is 0, so we're going to be able to factor that out. So that's going to be 0. So now we have 0. What do we factor out? What's our greatest common factor? Okay. Well, 16 goes into 144 9 times. So our greatest common factor is negative 16. So I have negative 16 times t squared. That's 0, so we ignore that. Okay, minus 9. And you should be happy with this. This is an easy factoring problem. All right, so in this case, we can just keep going because we're going to get 0 equals negative 16 perfect square minus perfect square, t times t, 3 times 3, and my signs are plus and minus. Okay. So now we're going to get t plus 3 equals 0. And we're going to get t minus 3 equals 0. So t is equal to negative 3, and t is equal to 3. You show both answers. Okay, so remember this parabola, if I were to complete it going this way, imagine if you completed it going this way, that's why you get the negative 3. So we disregard that. So the answer in words, okay, So answer in a sentence. The brick lands on the ground 3 seconds after it falls. And I really do think the pictures are going to help you with vertical motion problems. So I really want you to draw these pictures. Very simple, just a little sketch. Now I want to review doing this problem with the quadratic formula. And after this, you can use whichever method, factoring a quadratic formula, to do your homework problems. So we have 0 equals, we're using this, negative 16t squared, okay, plus 0t plus 144. So a equals, and you didn't have to write the 0t, but it's fine if you do. A equals negative 16, b equals 0, c equals 144. Okay. So now I'm going to plug it in to the quadratic formula because we're looking for t, time. We're going to use t. The opposite of 0, okay, well, that's just 0. So you didn't have to put negative 0 because 0 is 0. Plus or minus the square root b squared, well, 0 squared is 0, minus 4 times a, which is negative 16, times c, which is 144, all divided by 2 times a. So I want you to take your handy dandy calculator and figure out what that number is. So we're going to get t is equal to plus or minus whatever number that is under the square root divided by negative 32. So making sure 0 minus 4 times negative 16 times 144. That's 9,216. And we're going to take the square root of that, and we'll be really happy if it's a perfect square. 9,216. So this is a perfect square. All right, so we can now split this into 2 pieces. T equals 0 plus 96 divided by negative 32. And here t is equal to 0 minus 96 divided by negative 32. So here, this is positive, this is negative, so I get negative. And it goes in 3 times, so I get negative 3. I've got 2 negatives here. T equals 3. So you can see that I get the exact same answer whether I factor it, okay, or whether I solve it with the quadratic formula. It's really your preference. The quadratic formula will work for every equation, but sometimes factoring is just so easy. So what I'd like you to do is finish this packet going through these problems. Okay, with the rest of the problems. And the answers are on my website. And if you have any questions, come see me. Have a good night.